Hi, my name is Olaf Diegel from Odd Guitars. Today I'm going to tell you a little bit about the manufacturing process behind my 3D printed guitars, just to give you an idea about the whole process from printing, assembly and so on. So possibly a good place to start would be to point out a few things about 3D printing. So though I talk about these guitars as being 3D printed guitars, really they're not. They combine just about every manufacturing process under the sun. The necks are CNC machined, the inner core CNC machined, the bridge is cast, all the plastic bits are injection molded. So this actually forms a really good example of showing how 3D printing is not going to replace traditional manufacturing, but is a complementary technology that if you use it in the right way can be very, very advantageous for certain types of components. So in this case I use it because it allows me to make incredibly complex parts that you couldn't make any other way. Possibly one of the other things that's worth pointing out is that these bodies are printed on very high-end selective laser sintering systems. So that's a high-end technology, and there's been a bit of confusion often where there's now been a proliferation of desktop 3D printers, sort of, $1,000 to $5,000 desktop machines that allow you to print basic stuff, test ideas, be creative. Very important to point out that those desktop machines are not the same as the high-end industrial printers, and what you can do on a high-end machine is not necessarily something you're going to be able to do on a desktop machine. Don't get me wrong, both are absolutely fantastic in their own right, and I think everybody should have one of these desktop machines at home. But what you can do on one of those is not the same thing as what you can do on an industrial machine. So back to the guitars. The whole design process starts in CAD, so in software on the computer, where you design the guitar. Now that can take 2 days, 3 days, it can take several weeks depending on the complexity you're going through. So I use SolidWorks because it happens to be the CAD package that I'm comfortable with. And in this case we start with a model of the guitar, and because it's digital, it's very, very easy to customize anything we want. So one typical customization I always make is to put the customer's name, for example, their logo or their band name on the back of the guitar. And that's as simple as editing a text field, drawing in a logo, putting it in, changing it to everything we want. So for example, in this case, I might decide to put my own name on the back of the guitar. And we go, grab the text field, and I'll put in Olaf as my name, perfect. And we might just move it over a little bit to say there. And once we're happy with that, we're ready to go, and the file is rebuilt in 3D, of course. And this could be any level of customization you want. Now, the more customization you do, the longer it takes, of course. So that is now done and ready to go. So once we're happy with the design, I convert the file to an STL file, which is the universal file format that all 3D printers talk, and email the file up to Cubify. So Cubify is 3D Systems' online printing network, where you can upload your files, get an instant price back, get it made, and you can also sell it through the Cubify network, which is a nice little service in a way. So I upload my files, and a few days later I get the bodies back ready for the next step of processing. So I thought first I'll just run you through the 3D Systems process of actually printing the guitar bodies, and then we'll talk a little bit about the following steps, about painting them all up and assembling them.
Selective laser sintering is a 3D printing technology that uses powder as the raw material. So it spreads a thin layer of nylon powder, and then a laser melts the powder only where it needs to. So in this case it's melting a slice of the guitar. Once it's done, it spreads another thin layer of powder on top of that, melts it again, and repeats the process again and again and again until the part is finished. Once the machine has finished its job, you get to basically play Dinosaur Hunter, where you dig your part out of a block of powder, and that's actually quite a bit of fun and quite a satisfying job, where you see your part gradually emerging from the powder. The powder, of course, gets recycled, and you mix virgin powder with used powder on every build. So once you've got the part roughly cleaned out, you then put it in a sandblaster just to clean up all the surface powder that's stuck directly to the plastic, and you basically give it a good sandblast to get rid of any powder that's stuck to it. And after that, once that's done, you just take it out of the sandblaster, give it a quick blow, and you're pretty much ready for paint. Now, the painting process for my guitars is actually quite a slow, painstaking process. So first we rough sand it to get rid of most of the layer lines that we can, and then it's a repetitive process of priming and sanding. You prime it first, then you sand it down, you prime it, you sand it. Typically it takes about 2, 3, 4 layers of primer to get a perfectly smooth finish on the outside that's ready to apply the color to. So once you've got the preparation done and you're completely ready, you're ready to start painting. But first, before you can do that, you've got to mask the guitar. Now, in the case of my guitars, it's actually a very complex job because every star, for example, needs to be individually masked so that when you paint, you only paint the bits that you want to. So again, quite a painstaking process that takes quite a bit of time. Once that's done, you're ready finally to apply the color. You apply the blue and the red. And once that's done, finally, it's a bit like unwrapping a Christmas present where you take off all the masking and you reveal all the work you've done that's taking hours and hours to do, but a really, really satisfying job to do that, to see your guitar appearing. Once that's done, it's really a couple of coats of clear to give it a good protective satin finish, and you're pretty much ready to start the assembly.
So essentially what you have here in front of me is essentially all the components that make it up. We've got the 3D printed body itself that was 3D printed and is now being painted and ready to assemble. We've got the wooden core of the guitar, the neck and the pickups and so on. And essentially these two bits form, I guess, what you would call the soul of the guitar. Neck bolts in there, pickups here, bridge here. This forms essentially the part of the guitar that determines a bit, I guess, its sustain and its acoustic properties. Personally, I like to use the same wood for the core as for the neck, so we've got a maple core, maple neck. If it was a mahogany neck, I'd use mahogany for the core, but that really depends on personal preferences and so on. Right, so the assembly process is pretty straightforward, and from here we can probably speed the video up to get the whole idea, and away we go. Right, so there you have about 3/4 of the guitar assembled, ready to go. So we've got the bridge on, the pickups on, the neck on, ready to go. And the next step now is to run the wires through to the control cavity and do all the wiring up. Now that should take me probably about an hour to do it nice and carefully. So see you in an hour. And there you have it, a completely finished Americana guitar.